can study about the satellite system. This is in the case of satellite. In the case of a satellite, you can see here. There is a earth station, and in the case of satellite, there will be earth stations will be there, and there will be a transponder. Normally, a satellite all the satellites are used for communication purpose. Almost all of the satellites are used for communication purpose. Some meteorological purposes are also there for navigation purpose, and some other use are also there. And normally there is a term called as uplink, and there is a downlink. Uplink means normally the frequency or the signal that is sent from earth station to the satellite, and this is the signal that is coming from the satellite to the earth station. Normally the uplink frequency will be higher than the downlink frequency. That is, always it will be higher than the downlink frequency. That is, normally satellite frequencies are divided into L band, S band, C band, KU band, K band, KA band, like that. L band is 2 to 4 gigahertz, S band 4 to 8 gigahertz, like that, and the KA band 30 to 40 gigahertz. So normally the television receiver, normally you might be using the Videocon or Sun network, that kind of thing. So that kind of that is also a satellite. You are only able to receive. You are not able to transmit in that case. You can receive the frequencies in this range. And here you can see that as the frequency increases, the antenna phase reduces. That we have seen in the radar also. In the radar also we have seen that in the radar education we have seen the relationship between the lambda and the antenna phase. That kind of things we have seen. So here also the same is the case. So normally the antenna used will be a parabolic dish, and here you can see an uplink. Normally if you are using L band, the antenna size will be very higher. If you are using the K band, the antenna size will be lower. And here itself you can see 30 to 40 gigahertz. 30 to 40 gigahertz means 40 gigahertz will be used for the uplink and 30 gigahertz will be used for the downlink. That will be the case. 30 to 40 means that will be the case, because I am giving a generalization. Suppose 2 to 4 gigahertz. So 2 gigahertz will be used for the downlink. 4 gigahertz will be 2 to 3. 2 to 3 may be used for the downlink, and 3 to 4 may be used for the uplink. Because normally it is not easy to generate high frequency at low power. Normally there is a power limitation in the satellite. Normally the power in the satellite will be from solar cells only. So we cannot generate very high power in the satellite. So we can generate low frequency comparatively better than high frequency in the satellite. So that is why the uplink is higher than the downlink. Uplink is higher than the downlink. Downlink is normally lower. Uplink is higher. So there will be a user that can be a mobile phone user. Then there will be a terrestrial system means that can be a mobile network. And again an earth station. Earth station means converting this so many uses may be there. So all these uses are combined by using some TDM technique, and finally it will be using one frequency. We may be using the upper frequency, 4 gigahertz may be using, and we will send that signal to the satellite. And here there is a frequency converter. We have seen in the case of what is a transponder? Transponder means actually it consists of a receiver and transmitter. It is receiving a signal at high frequency. And converting that signal to a low frequency. That is, it may be receiving the signal in the 4 gigahertz and after receiving, so transponder consists of both a receiver and a transmitter. Here also there can be transmitter and receiver. And in the case of a satellite system, there will be a receiver and a transmitter. It is receiving the signal at high frequency, then it will convert the frequency to a low frequency, that is a down converter is there. Down converter means what will be the thing in the down converter? Normally a frequency conversion means we are mixing it with some signal. So we will use a down converter, and that signal will be come back, sent to the another earth station. So these earth stations may be at remote location. This may be in India, this may be in Japan or America. So one earth station is at different places of the earth. So different earth stations can be at different locations of the earth. And here, after receiving the signal here, it can be sent to different mobile networks or like that. And here, earth stations can be near also. That is, your TV network is an earth station. Your TV receiver, LNB, that kind of things. You might be using dish TV. You might be using Videocon, that kind of things. So all these are earth stations. But you do not have permission to transmit. But in the case of a telephony, you have got you can send signal and receive signal. So that is what is actually happening in the satellite system. This is the block diagram of a satellite transponder. So it is there in the satellite. So in the case of transponder, I have told you previously, there is a signal that is receiving at a high frequency, and again it is converting into a lower frequency. Here we are receiving a signal at 6 GHz and transmitting down to earth at 4 GHz. So from 6 GHz to 4 GHz there should be a converter is there. So this is a receiving antenna. So in the satellite there will be antennas will be there for receiving the signal. So there is a 6 GHz antenna and there is a 4 GHz antenna. So 6 GHz, through the 6 GHz antenna the signal will be received, and this is a LNA, low noise amplifier. Then there is a down converter. Down converter means converting this frequency, 6 GHz frequency into 4 GHz frequency. So here again there is an IF is also there. So here there is a local oscillator is there. So 6 to 4 means there will be a local oscillator frequency should be 2 GHz, around 2 GHz. So when we are mixing it with 6 GHz, we will get we can get a 6 plus 4 and 6 plus 4 and 6 minus 4. That is, you will get 6 plus 4 means it will be 10 GHz. When we are mixing it, there is a possibility to get 6 plus 4 and 6 minus 4. We are taking only 6 minus 4, that 6 minus 2. That is 4 GHz, and that will be amplified, and there will be a high gain power amplifier, and that will be sent to the earth station through this transmitting antenna. So this is we are having two antennas. One is a receiving antenna, and that is designed for higher frequency, and there is a transmitting antenna that is designed for a lower frequency. So all these things will be in the satellite. This is the block diagram of an earth station receiver. We have seen there will be an earth station transmitter and there will be an earth station receiver. So in the earth station receiver there will be an antenna. So this is the signal received from the satellite, and it will be a lower frequency. If it is a transmitter, we are sending it and it will be high frequency, and we are receiving a signal at low frequency. That is, in the case of 6 to 4 converter, 4 GHz we are receiving 4 GHz here, and here this is the antenna, and there is a low noise amplifier, again a band pass filter, and here also a mixer is there. So there is a first local oscillator. So this is a double conversion receiver. and again band pass filter, and again IF amplifier, again a band pass filter, then second mixer, second local oscillator, band pass filter, second IF amplifier, and again demodulator. So this is our suppose audio signal or like that, audio signal or data, anything, it can be anything like that. Here the frequency is very high, that is why we are using a double conversion receiver instead of a single conversion. Previously also we have seen the advantages of super heterodyne receiver. Instead of a single conversion, we are using, in the case of super heterodyne receiver, we are using a double conversion. There will be a mixer, that kind of things. We have seen the advantages of having an IF. So here also 2 IF stages are there. That is the case with a satellite receiver.